Okay, so here we are with part 2. We're going to continue where we left off, so right with this problem here. Let's go ahead and have you try it. So pause the video, try to verify the identity, unpause when you are ready to discuss. Alright, so which side did you work with? I worked with the left-hand side. Now, you might ask yourself, well, how do I know that that side's more complex or more complicated compared to the right-hand side? Well, it's two terms separated by subtraction, and the right-hand side, although there's two trig functions, it's technically one term. So the left-hand side is more complex because it is two terms. So, what did I do, though? What was I thinking? Well, I'll be honest, the first thing I was thinking was, and remember, you have to only work with one side, but it doesn't mean you can't think about the other side. And so, in my head, I thought to myself, tangent is the same thing as sine of x over cosine of x. Now, why did I think about that? I thought about that because on the left-hand side, I have secant of x and I have cosine of x. And I can change secant of x into 1 over cosine of x, which gives me a denominator of cosine, which is the same as this, because I can make that a denominator of cosine. So, back to what I did, I changed secant of x into 1 over cosine of x, and I left this cosine of x. Now, I thought to myself, well, how do I take two terms and combine them into a single term? Well, if there's a fraction, I need a common denominator. So I multiplied the numerator and denominator of the right-hand term by cosine of x over cosine of x. So this became cosine squared of x over cosine of x. Now I have my common denominator. Now I can combine the fraction. 1 minus cosine squared of x is conveniently my Pythagorean identity, which is sine squared of x over cosine of x. And now I might ask myself, well, wait, how do I change that into sine of x times tangent of x? Just split up sine squared of x, right? If you have a quantity squared, like if I have x squared, I know that that's just x times x. So I can take sine squared of x and make that sine of x times sine of x, and then I can group them how I want. And so that's what I'm showing you here with the parentheses, is I'm choosing to make one of the sines be over the cosine. Then that changes it to tangent, so I get sine of x times tangent of x equals sine of x times tangent of x. Fantastic. Last one. So, try this one on your own. Pause the video. Unpause when you're ready to check. Okay, so here I actually I'm going to show you two different ways to do the same problem. They're both really kind of doing the same thing but opposite order. But here, this is a good problem of where maybe you look at it and you're like, I don't really know which side is more complex. I would maybe argue the right side is because of the subtraction, similar to what I argued on the previous problem. So that's why I worked with the right-hand side first here, but I'm also showing you down here how we could work with the left-hand side. So anyway, if I choose to work with the right-hand side, what's my thought process? My thought process is I have a sine squared of x minus sine to the fourth of x. I know I need a sine squared of x in my answer, so I'm going to factor out a sine squared of x from these two terms. Conveniently, that leaves me with 1 minus sine squared of x, which conveniently is cosine squared of x for my Pythagorean identity. So this sine squared of x just comes down here. This 1 minus sine squared of x becomes cosine squared of x, and I still have this cosine of x here. Cosine squared times cosine is cosine cubed of x, and then I have my sine squared of x. I just rewrote it in a different order so that it matches what I had on the left-hand side, but that's my answer. Okay. Well, what if I chose to work with the left-hand side? What would my thought process be? My first thought process would be a cubed really doesn't help me at all. So what can I do with that? Well, if I have something cubed, so again, I talked about this on a previous problem. If I have something like x cubed, I can think of this as x squared times x, right? On a previous problem, I said if I have something like x squared, I can make it x times x. Well, that's what I'm thinking of with cosine cubed of x, is I'm making that cosine of x times cosine squared of x, and then I still have my sine squared of x. Now, cosine squared of x is 1 minus sine squared of x. How would I know to do that? Well, I know I need to introduce subtraction because my answer has subtraction in it, right? And I know that I need to preserve the sign squared because my answer with the subtraction has signs in it. So my other option, right, to create subtraction is I could have changed sine squared of x into 1 minus cosine squared. But then the subtraction would have the cosines. I want the subtraction to have the signs. So I change the cosine squared into 1 minus sine squared. Now I can distribute, and I get my answer. That's verifying trig identities. That was fun.